Hi friends, today I am giving a lecture on Hamming code. Hamming code is one of the most important concept in error detection codes. It is one of the error detection technique. Hamming code is a error detection technique developed by R.W. Hamming to detect errors in the given message. Hamming code is mainly used for detecting single bit errors. It cannot detect multiple number of errors. Suppose we can take a message, the source can send a message by adding some number of parity bits or redundant bits and insert these parity bits at particular position in the given message to accomplish error detection and correction process. Okay, what are the main applications of Hamming code? The main applications of Hamming code is used in satellites, modems, and computer memory. In these three applications, we have to use Hamming code. Okay. Next one, the process of encoding a message using Hamming code includes the three steps. The first step is calculation of total number of parity bits. How to calculate the total number of parity bits that we have to add in a given message when the message contains m number of message bits. Okay, here P is nothing but number of parity bits. So the parity bits or redundant bits we have to add in the message. Okay, how many number of parity bits that we have to add for a given message by satisfying this formula 2 power p greater than or equal to m plus p plus 1. Here m is nothing but number of message bits, p is nothing but parity bits. So 2 power p greater than or equal to m plus p plus 1. If the condition is satisfied, then p is nothing but number of parity bits that we have to add. Okay, once the p value is calculated by using this formula, so then total number of bits is equal to m plus p. M is nothing but number of message bits, p is nothing but number of parity bits. Okay, in this first step, calculation of total number of parity bits. Okay, in the given message, only the total number of message bits can be denoted by m. Okay, the total number of parity bits that we have to add for a given message, so calculated by using this formula 2 power p greater than or equal to m plus p plus 1. If this condition is satisfied by knowing the m value, then we have to calculate the p value. Once p value is calculated, then the total number of bits is equal to m plus p. Okay, next one. Once we are calculating the how many number of parity bits that we have to add for a given message, now we have to place the parity bits in their correct positions. Okay, so p parity bits can be placed at bit positions of powers of 2. Powers of 2. Here p1, p2, p3, p4 are the parity bits. Okay, P1 is located at 2 power 0 position and P2 is located at 2 power 1 position. P3 is located at 2 power 2 position and P4 is located at 2 power 3 position. Only parity bits are located at bit positions of powers of 2. Here 2 power 0, 2 power 1, 2 power 2, 2 power 3. Only at powers of 2 positions we have to place the parity bits. Okay. Next, the remaining positions, that are third position, fifth position, sixth position and seventh positions, we have to place the message bits. Okay. Now, how many number of parity bits are there? There are 4 parity bits are there. How many number of message bits are there? 4 message bits are there. Total number of bits is equal to m plus p. M is nothing but 4 and p is nothing but 4. 4 plus 4, that is equal to 8. So m plus p is nothing but 8. Okay. So here how we are getting? Here m is equal to 4. Number of message bits is equal to 4. Then how to calculate the number of parity bits required? 2 power p, so greater than or equal to 4 plus p plus 1. Okay, suppose p value we have to take 3, so 2 power 3 greater than or equal to 4 plus 3 plus 1. So that is 8 greater than or equal to 8. So this condition is satisfied. Now m is equal to 4 and p is equal to 3. So in this way, we have to calculate the total number of parity bits that we are required. So now m plus p is equal to 7. 4 plus 3, that is equal to 7. Once we are getting the how many number of parity bits, that parity bits are placed at 2 powers positions, 2 power 0, 2 power 1, 2 power 2 and etc. Okay, next one. Third one, calculating the values of parity bits. Once we are calculating how many number of parity bits are there, once we have to find out these parity bits are located at powers of 2 positions, then how to calculate the parity bit value? Okay, so before going to that, the parity bits makes the number of ones either even or odd. Okay, once we are adding the parity bits to the message bits, the total number of ones may be either even or odd. Okay, so here there are two types of parities are there. One is odd parity and second one is even parity. Odd parity is nothing but the total number of ones in the given message so is even, then it is called as a even parity. The total number of ones is odd, then it can be called as a odd parity. Okay, if the total number of ones is even, then it can be called as a even parity. The total number of ones is odd, then it can be called as a odd parity. Okay, once we are find out the odd parity and even parity, okay, then how to calculate the parity bit value? The parity bits calculated by using this example. Suppose a given message is equal to 1010. So therefore number of message bits, how many number of bits are there? 1, 2, 3, 4. Therefore m is equal to 4. Number of parity bits required is calculated by using this formula. 2 power p greater than or equal to m plus p plus 1. Here we know only the m value, m is equal to 4. After substituting m value 4, so based on the condition, we have to calculate the p value. Suppose p value we have to take 3, 2 power 3 greater than or equal to m value 4, p value 3 plus 1, 8 greater than or equal to 8. So that is true. So therefore, number of parity bits P is equal to 3. Next, total number of bits is equal to number of message bits plus number of parity bits. Here message bits is 4 and parity bits is 3. So 4 plus 3 is equal to 7. So now here these 7 bits can be represented in this way: 1, 2, 3, 4, 5, 6, 7. Now parity bits are located at bit positions of powers of 2. Powers of 2 is here, this is 2 power 0. 2 power 0 is equal to 1. Next 2 power 1. 2 power 1 is equal to 2. 2 power 2. 2 power 2 is equal to 4. But here 2 power 3 is not there because 4 plus 3 is equal to 7. Total number of bits. Okay. Here at 2 power 0 position parity bit P1 is there. At 2 power 1 position parity bit P2 is there. At 2 power 2 position parity bit P3 is there. Next the remaining bits. So the message bits we have to insert, that is M1, M2, M3, M4. Here M1 value LSB side, that is 0, and M2 value is 1, and M3 value is 0, and M4 value is 1. Okay, so this is LSB and this is MSB. Okay, based on that we have to insert these values. Now we have to calculate the parity bit P1 value, parity bit P2 value, parity bit P3 value. Okay, so here there are 7 bits are there. So 7 bits can be represented as 0, 0, 1, 0, 1, 0, 0, 1, 1, 100 101 110 111. So this is the decimal equivalent of 1, decimal equivalent of 2, decimal equivalent of 3, decimal equivalent of 4, decimal equivalent of 5, decimal equivalent of 6, decimal equivalent of 7. Now parity bits are calculated. Parity bits P1, P2, P3 are calculated as okay, first we have to take P1. So P1, while you are calculating P1, okay, we have to consider the LSB, least significant position, where the 1 is there. Okay, here 1 is there at 1th place and 3rd place and 5th place and 7th place. Okay, so now consider this. While calculating P1 value, we have to consider the LSB position column. In that LSB position column where the 1 is there. Here 1 is there at 1 is there in this position, 1 is there in this position, 1 is there in this position, 1 is there in this position. 1, 3, 5, 7. Okay. So now at 1th position, what is the value is there? Here P1 is there. Okay. Next at 3rd position, what is the value is there? 0 is there. At 5th position, what is the value is there? That is 1. Next at 7th position, what is the value is there? That is 1. Suppose the given message is sent with even parity. The given message is sent with even parity. Okay. So based on that even parity, here what is the value of P1? Okay. Suppose in this message P1011, how many number of ones are there? 2 ones are there. It is already even parity, so that P1 is equal to 0. So therefore 0, 0, 1, 1. So this is a even parity. So therefore P1 is equal to 0. Okay. So now calculating P2. So P2 is equal to, now consider the next column. After LSB column, next we have to consider this column where the ones are there. So the one is there at second position, next third position, next sixth position and seventh position. Okay. So now in the second position, what is the value is there? That is P2. Next, in the third position, what is the value is there? 0. In the sixth position, what is the value is there? 0. In the seventh position, what is the value is there? That is 1. Okay. To become this message even parity, what is the P2 value? If the P2 value is 1, then two ones are there, then it becomes a even parity. So therefore, P2 value 1, 0, 0, 1. So then it becomes a even parity. Why we are taking even parity? The message is sent with even parity. So because of that reason, the total number of ones in the given message is even number. Here only one single one is there. To become this message is sent with the even parity. So P2 is equal to 1. Okay. To send this message with the even parity, already two ones are there, then P1 is equal to 0. Okay. Now calculating P3 value. So now consider the MSB column. MSB column where the 1 is there. 1 is there at 4th position, 5th position, 6th position and 7th position. Okay. So now at 4th position, here P3 is there. In the 5th position, 1 is there. In the 6th position, 0 is there. In the 7th position, 1 is there. Okay. So that is P3 1 0 1. How many number of ones are there? Without considering P3, two ones are there. Two ones is nothing but 2. 2 is nothing but even parity. The message is sent with even parity. So by considering this one, P3 value 0, then it becomes a 0 1 0 1. So it is already two ones are there. Then it is sent with even parity. Okay. So therefore P3 is equal to 0. Here therefore P2 is equal to 1. Okay. Once we are calculating that P1, P2, P3 value, identify the error position. Identify the error position is equal to P1, P2, P3. What is P1, P2, P3 value? P1 value is 0, P2 value is 1 and P3 value is 0. What is the decimal equivalent? That is 2. Okay. So the error is located at second position. Second position in the message. Okay. In the message, the second position. So the total message we are required is, after calculating the parity bits, so 1 0 1. Next P3 value is 0, M1 value is 0, P2 value is 1 and P1 value is 0. Okay. So this is the second position. So the error is located at second position. Error is there. So to correct that error, change the bit from 1 to 0. So that is error correction. After correcting this error, so 1 is changed to 0. 1 becomes 0. So this is the error correction process. Okay, 1 can be changed to 0. Okay, so this is the final one. Okay, in this way we have to identify the error in the given message while adding the parity bits. For that purpose we have to use Hamming code. Thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name. So DIVVELA Srinivasa. Okay, here the error is located at second position. This is the second position in the given message. After calculating the parity bits, the error is located at in this position. Now this bit can be changed from 1 to 0 by correcting the parity bit value. Okay. After correcting the parity, after correcting that bit value, the message comes 1010000. Okay, so thank you for watching this video.